Today we'll mainly be focusing on 30, 60, 90 degree triangles. Now, we give it that name because they have these 30, 60, 90. They have these three angle measures. Now, the very, very special thing about 30, 60, 90 degree triangle is if we take the midpoint of our hypotenuse, you might say CB in this case, and then connect it to point A. Not very accurate, but at least it works. If we connect it like this, we see that this little triangle down here, that's an equilateral triangle. And what's more special is that this little length, we can call this D, that DB is half of our hypotenuse CB. DB is half of CB, and since this is an equilateral triangle, this equals this, which is half of our whole hypotenuse, meaning that in a 30, 60, 90 triangle, the short side is always half of our hypotenuse. That's the special point. Now, another very special point is we can also make this into a very similar equilateral triangle. This is most useful for, or I might say that's most coolest part. We can take two copies of the same triangle and get an equilateral triangle. And we can prove that by seeing this is 30 degrees, since this is the same thing as this. These are two equal triangles. And then seeing this is a right angle because this is a right angle. 90 plus 90 is 180, that's a straight line. And 30 plus 90 is 120, we need 60 more degrees to finish a whole triangle. And then we see this is an equilateral triangle. 60 degree here, 60 here, 60 here. So that's an equilateral triangle. Now we got the main idea of a 30, 60, 90 triangle down. We'll move on to the problem. Get this over. Oh, sun's coming out, gotta be quick. Okay, so problem is, say that we're gonna start off with two 30, 60, 90 degree triangles. Let's see okay, there we go. Say we have, this could be 30 degrees, that's not 30 degrees. And let these two be 60 degrees. This is another 60 degrees. So we start off with two 30, 60 degree 30, 60, 90 degree triangles. And then we're told that the hypotenuse of one of these, that's 16. Now we just learned that the base is always, that the short side of our 30, 60, 90 degree triangle is always half our hypotenuse. So that means this is A, and using the most useful part, we see that if we flip this over, if we take another copy of this, flip it over, get this whole equilateral triangle, and since this is 16, this is 8, 8 plus 8 is 16, that means this is also A. And using our degree finding skills, we see that this is also a 30, 60, 90 degree triangle because, well, this whole side, that has to be 90 degrees since this is 90 minus 60, this is 30. This is the right angle because that's 1. And we can then see that it has to be 60 degrees. I will mark that we're running out of space in this itty bitty triangle. Now that we know this whole thing, that's an equilateral triangle, meaning this is 16, that this whole length has to be 16 as well. But that includes this little bit dotted lines. So if we just take our 16 and subtract off this little bit, this part of the dotted line here, then we get this side, and that's what we're looking for. Sorry, I forgot to tell you what we're looking for. With that little question mark, that's what we're looking for. So then we have to figure out this side length, and using the coolest part about a 30, 60, 90 degree triangle, we see that when we copy this, the base, you could call it a base, but then you could say, but also the short side is always half the hypotenuse, meaning this is for we have our dotted lines. Means this part, we just take our 16, subtract 4, and we have 12.